Hello there, and welcome to our session today about eye gaze technology and what you need to know about it. My name is Hannah Erickson, and I am from the support and training team here at IRISBOND. So to start out, I just want to give you a little bit of context about us, IRISBOND. As it says there, it's really nice to meet you. We are an eye gaze manufacturer and consider ourselves to be experts in eye gaze. So as eye gaze experts, we really want to inspire the society to change the way we communicate with our environment. So using eye gaze as a natural means of interaction communication is our top priority. So what we do as a team here has a social impact on many levels, and we're really proud of that. We take our work really seriously, but we take on everything with positivity. And here at IRISBOND, we like to say that we make the impossible possible. So that's really our goal and what we believe is our responsibility. We're not only eye gaze manufacturers, but we also have this responsibility to help people get it into the hands of as many people as possible. So as a team, we like to challenge ourselves and invent global and unique and innovative products that facilitate our relationship with everything around us. So as we say, see it possible. If I were to describe IRISBOND in one word, it would be daring. That's because we consider ourselves to be a company without fear. So things like mistakes and hurdles and challenges are something we view more as an opportunity than a downfall. So we always use those opportunities to learn and grow and push forward. So although we develop a technical product, those eye gaze cameras, we prioritize people. And to do that, we make sure that we are in contact with our users, and we welcome questions and comments because we love to answer any questions and help out whenever we can. So this is a little bit about us. As you may know, we're a team based in the north of Spain, and we have an international reach and a drive to grow. And here's how we see our technology in the world today. First off, we see it as open. We are an open technology platform for everyone, everywhere. We don't want to limit ourselves to any place in the world or any type of user. We are also wide. We live in a diverse and inclusive world full of opportunities and possibilities, and we want to take advantage of that. And lastly, we are live. We are a live society. We want to promote that thinking and sharing and positivity in order to learn and grow and move forward. So let's take a quick look at our at IRISBOND and our video that we have to show a little bit about who we are. So as you could probably see in our video, we've developed our own devices, eye gaze cameras like Hiru, which I have here. And we've also developed our open SDK, which is a roadmap for creating compatible programs to go with eye gaze cameras like Hiru. So while doing that, we've partnered with many different companies and organizations such as Microsoft, Samsung, Twitter, and MIT. And we would like to continue to do that. I'll get into a little more detail about what that looks like later. So now that we've seen a little bit about IRISBOND's culture and what we look like as a team, now I want to talk a little bit about our main products. So the biggest product and the most important product we make is Hiru, as I said. And this product is very interesting for us because it is a multi-platform eye tracker, which is the first one in the world. And what that means is that you're able to use the same eye tracker in more than one operating system, which is really nice. Other unique features from Hiru come in the little details. So for example, we have some user-friendly features like this calibration button that you'll be able to use in some softwares. We'll look at that a little later. And the detection indicator light on the front of Hiru. We'll see that when you're able to, when your eyes are detected. And lastly, Hiru really represents IRISBOND as an organization, also because it is always able to improve. So because Hiru has on-chip technology, we are always able to update remotely the capabilities of the camera, and we're able to do that all from, you don't need to be together. You can do that remotely for all users, so that the new technology and the new updates are in the hands of users in the blink of an eye. Okay, so now that we've seen a little bit about who we are as IRISBOND and where we're coming from, as well as what we create, let's take a look at the plan for today. So today we'll see some features of eye gaze technology that are new to AAC. We'll compare different styles of AAC eye gaze apps and look at some best practices in eye gaze. So let's go. To cover all of these learning points, we're going to show you a few different trends that we think are coming up in 2022. So we'll talk about usability, support, flexibility, and data. So first of all, usability. If you've ever worked with eye gaze at all, you know how important it is for an app to be user-friendly and eye gaze friendly. So one of the most important things when it comes to making something eye gaze friendly is integration. So integration is when an app is designed with an eye gaze camera in mind. I won't get too much into detail, but if you've ever used an eye gaze computer control software versus something like an accessible app in an integrated app like Grid 3 or another AAC app, you'll probably notice that there's a difference. And you'll know that working within an app like this one that you can see here on the right, that accessible app, you'll know that working with an accessible app or a more integrated app has a big difference in the ease of use. So when we talk about integrations, the integrations are the key to ensuring that usability and eye gaze friendliness. To give a little bit of context about eye tracking integrations, I'll tell you a little bit about how eye tracking works. So eye tracking works because the technology in the eye tracker estimates the exact place where a user is looking on the screen. And it communicates those to a program using X and Y coordinates. So when an app is integrated, different coordinates or areas on the screen are dedicated to different commands. So for example, you can see on the right-hand side of our integrated app image, you have different buttons. For example, the one on the top, which is pointing to the left, a left arrow. So any eye gaze point with those X and Y coordinates that is within that square, or within that button, is going to be understood by the app to mean that command. So if I click next to, in any place within that square, I will be able to move one cell to the left. And in an app that's not integrated, that looks a little bit more like the one, the photo that you can see on the left. These zones of coordinates don't exist. So what happens is that the computer or the tablet must understand the exact gaze coordinates right down to the size of a pixel, which means that it's a lot more difficult for the user and the eye tracker to click. So often with using eye gaze, if you're looking at a certain point, the cursor might move a little bit as you're looking. And that might be due to the user themselves looking around a little bit, or might be due to the length of the dwell time, or just because some users might have involuntary movements in their eyes or other situations like that. But the biggest thing is that in an app that's not integrated, all of those things might get in the way of clicking, because you'll have to look at one small point for the entire dwell time in order to click. And that makes it for kind of an uncomfortable experience. So one of the main differences with these integrated and non-integrated apps is between making a click on a single pixel versus on that whole button, as you can see in the integrated app on the right. So basically, as a result, a lot of mature operating systems like Windows have a lot of integrated apps with eye gaze already, and those are pretty much the standard. What we want to do at IRISBOND is continue and expand that, making more integrations in all operating systems. Before we move on to anything else, though, I want to do a quick demonstration of everything I just explained and what it looks like, because I think it's a little bit easier to see than to hear it explained. So what I'm going to do is share my screen, and I'll plug in my Hiru camera in order to show you what it looks like. Okay. So now you'll see my whole screen. And I'm going to open first an app that is a computer access software. And this will be possible to use to control the computer and to click on, basically to imitate a mouse, clicking on different options throughout the computer. But it's not an integrated app. So first I'm going to do a calibration just to make sure I have good accuracy. Okay, so now I'm able to control all of these things with my eyes, but as you might be able to see, this app is not integrated. And each button, each place that I click, I need to click on just as if it were a normal mouse. So it takes a little bit longer to click. So now, just to show you an example, I'm going to look and use this app, EasyClick, over a communication app. And then we're going to compare what it looks like when it's integrated. So now I have to choose what kind of click I want to do. Do that by choosing from the toolbar above. And I can click on different areas in the app. You can see how the mouse is moving around a little bit as I'm going through these clicks. And that's because each of these cells, each of these keys are not separated by the integration the same way that it will be in just a moment. So you can see it's a little bit difficult to click on different items here. Kind of just clicking on random areas on the screen to give you an idea. So notice how as I'm clicking on different keys, the mouse is kind of shifting around the screen and gliding slowly. It might not grab onto each key. Okay, so now I've erased this. Okay, so what I'm going to do now is close our computer access software. And then I'll show you an example of an integrated app. The integrated app we're going to see now is called Grid 3. A lot of people know this one in AAC and in eye gaze. It's very complete and is actually, like I said, integrated fully with our eye gaze camera, Hiru. So as I'm going around this app, you can see that I have some feedback already as I'm clicking. So that's one difference you can see. I'm going to go back here and go into the same app that we used before. Now, as I'm clicking through or looking through all of these keys, you can see that each cell is highlighted as we go. And you don't see that extra movement that we saw with the non-integrated app.
Thank you.
My voice is in Spanish because, as you know, we're based in Spain, so it sounds a little bit strange. You might see some words you don't recognize. But you can see this difference with how the mouse moves throughout the keyboard. Okay, I'm going to close this and let's go look at a few other examples of what integration looks like. Let's see one more example about how an app, when it's integrated, can make eye gaze really easy. Here we have an app that's integrated with our IRISBOND camera and connected to a coffee machine. This is thought of as an easy solution for touch-free coffee ordering. So when I put myself in front of this app, I can see that these buttons are very large. And so it'll make it really easy to click. Now that the app has done a quick calibration for my eyes, I can click anywhere inside one of these buttons and it will start. So now that we've seen the main reason that integrations can help with eye gaze, let's look at a few other ways that integration can improve the experience with eye gaze. So let's go to this integrated app, Grid 3, and we'll see that we can really personalize the experience. So, first thing that's really great for an integrated app is to check the positioning. Now, positioning, as we know, is really important in eye gaze. So with Hiru and Grid 3, the integration has allowed us to have two options for that. First, we have this avatar, and we have a video view. Here I'm really able to see if my eyes are detected or if I need to position the solution in a different way in order for me to use the eye gaze properly. Now let's go into a little bit more of that personalization and visual feedback I was talking about. So within the activation of a cell, I'm able to choose how I want to see that interaction with my eyes. So I can choose if I want to click for dwell time, or by blinking, I'm going to choose dwell time. That just means that the longer I look at the cell, I will be able to click on it. We also have different options for how it will look while I'm looking at a certain cell. So here you can see I've chosen this shape and this orange color. So I can personalize a few other things as we go. Let's see how it looks when I use the app. Now, as I look at each cell, I'm able to see what it looks like and click as I go. All right, let's take a look at another solution with iOS. In iOS, we have another integrated app called Predictable. In this app, it's a really comfortable use of the eye gaze because the integration is so quick. So when I position myself correctly and my eyes are picked up, I'll I'll be able to start using the app right away.
Hi there.
All right, so that's one example of what it looks like to use this integrated app, but there's even more to it. So when I use Predictable, I'm able to control all of these settings with only my eyes. I don't need to touch anything. So once I go into the eye gaze settings, I'm able to control things like the visual stimulation or the visual response you get from clicking on a certain cell with only eye gaze. So here I can choose timer or shrink. Right above there, I can look at if I want the cursor to be visible or not. And going up the line, I'm also able to enable what's called a cursor snap, which is actually just a feature that draws the cursor into the center of a cell, making it a little more comfortable experience. So now I can go back and continue typing as much as I want. So as we've seen, a great integration can make a big difference in usability, user friendliness. So that's the ability to control the app comfortably with eye gaze. You're also able to configure and personalize things within the app according to what works best for each user. And visual effects and indicators can make the interaction a lot simpler and a lot more comfortable. So as I said before, our goal at IRISBOND is to really create as many apps as possible with this type of integration, so we can just give more options to eye gaze users. So that's why at IRISBOND, we have this open platform SDK. That's the roadmap that I was telling you about before, that shows how to integrate our camera into apps like this. So anyone can integrate our camera and make the app really user-friendly for eye gaze. We don't put a limit on that at all. So we are well on our way with various integrations in Windows like Grid 3, Mind Express, and others. And we will continue growing that into 2022, both in Windows and in other operating systems. Okay, let's go on to our next trend, which is support. So as we know, eye gaze can require some learning and support in order to get the most out of it. And here we can just look at a few ways that eye gaze can be made easier and what we're doing at IRISBOND to make that happen. So as more and more people are using eye gaze, as I said, it's really, really important to get the support that they need out to those users, the therapists, the centers, the schools, and the families that are all using eye gaze or helping someone who's using eye gaze. And it's really important for those resources to be personalized and really useful for the end user. And because every user is unique, there's a lot of different solutions and software out there. So we want to make sure that each of those software options, as well as the eye gaze cameras, have sufficient support. So the support resources that we provide here at IRISBOND aim to be very inclusive and bring the power of eye gaze to the user itself. So we really uphold the ideas that all the support and the eye gaze system should fit the needs and preferences of the user and not the other way around. So our, everything from our positioning guide to any help or tips and tricks, we always try to promote flexibility and openness in those resources. Let's take a look at what those resources are. So IRISBOND has kind of 4 areas that we like to highlight as our support resources. The first one is on-site trainings or online trainings. We can provide training to partners all around the world when needed. Locally, we visit centers here in Spain, and we are able to provide those resources to families and centers and educational associations that might need that support. We also provide product demonstrations so that therapists or distributors or our partners around the world are able to stay on top of the most recent trends and products that are available for users, and also to get a better idea of how to test the cameras and evaluate eye gaze systems. Another thing that we have here at IRISBOND are software courses and tutorials. We like to provide really easy to use resources, and we're always adding to our library of resources. So some useful videos we have available now are tips and tricks about how to use eye gaze. We also have some information on how to use eye gaze software, all in video format. So we'll take a look at those in a little bit. And lastly, we do provide customized support sessions. So if our users or our partners have issues using the camera or questions, we are happy to take the time and connect one-on-one to provide that extra support. And before we jump into the resources and the videos themselves, I just want to talk about a few best practices when using eye gaze, because it's just an easy jumping off point to get started. So first off, in eye gaze, we know that positioning and setting up the eye gaze system is pretty important. So one thing that you want to make sure that you're doing when you are setting up your eye gaze for the first time is to put the eye tracker underneath the tablet. Or underneath the computer or tablet or iPad or whatever it is that you're using with your eye tracker. You want to place the eye tracker underneath, and it's aligned, make sure that it's aligned with the screen so that it's not crooked. And then from there, you'll have to check your position or the position of the user in front of the screen. We saw how to do this in grid 3 using that video feed or avatar positioning guide, but it's always good to just make sure that the eye gaze system is seeing your eyes before you start trying to calibrate or do some eye tracking. In order to get the best detection or eye tracking during the experience is to avoid direct light on the eye tracker itself and on the user's eyes. To do this, you can just kind of turn yourself to avoid those reflections and use that video feed in the positioning guide that we saw earlier. This will be super helpful if you are in a bright light and you have a reflection on your face or on glasses, so that you can have the best experience possible. But we'll go into a little more detail right now with these support videos. We'll look at some positioning and some suggestions for using glasses and other complicated situations.
When positioning a user for eye gaze, always remember that the user should be in a comfortable position, and the eye gaze solution should adapt to the user. Eye tracking is used ideally with screens between 10 and 20 inches in size, with the screen in an upright position and the eye tracker just below. The user should have their eyes in line with the top of the screen at a distance of 50 to 60 centimeters from the camera. The feedback ring on Hiru will indicate when the eyes are detected. Find a position when there's minimal direct light on the eyes or the camera. The avatar or video feed in the eye gaze application in use will show the ideal distance and positioning. Use these indicators to find the correct positioning before calibrating. If you're wearing glasses, clean them to get rid of light reflections, and tilt your head up and down to identify and avoid any reflections from the camera. Avoid using bifocals or metal frames when possible, as they can create extra glints for the eye tracker. If the detection is lost with glasses, try gently covering the frames with tape to block the reflections. In calibration, some special cases arise, especially with younger users. To keep the user engaged, here are a few tips. Personalize the calibration for the user. Everything from colors to speed to calibration points can be customized in most eye gaze software. In fact, in IRISBOND's Access software, EasyClick, you can even upload a personalized image for calibration. Invisible calibration and the Hiru's calibration button can also be configured to provide a quick one-point calibration to get the user back on track when a new calibration is needed. The fewer the calibration points, the quicker it'll be to get started learning. You can always build more precision in calibration as the user develops. For users with involuntary eye or head movements, here are a few tips. Use a step-by-step calibration, available in most AAC software, to have more control over the moment when the camera captures the calibration information. Wait until the user is positioned and gazing correctly, and trigger the calibration at that moment. Once the calibration is finished, you can also increase the smoothing level so that the mouse does not react so much to the involuntary movements. If needed, Hiru can be programmed to track only one eye. For users with eye conditions such as amblyopia, tracking only the user's dominant eye can provide a more convenient and smooth eye tracking experience.
Now that we've seen some of our support resources, let's move on to our next trend. As we've talked about already in this presentation, there's countless ways that people use eye gaze and countless different types of eye gaze users out there. So our next trend, flexibility, is going to be really important in the coming year. But really, let's talk about first what flexibility means in eye gaze. For us at IRISBOND, it means just having options. Eye gaze systems come in a variety of forms, costs, packages, all of that. And IRISBOND really tries to offer all of those things in one product, and that's Hiru. That's the camera we've been talking about. So the good thing about Hiru is that we are able to adjust the types of ways that you can mount, the types of packages you can buy it in, and the ways that you can use it. So the Hiru can be used by itself, all alone, or in some hardware integrations that we'll look at now. So talking about flexibility, we have a lot of different options that we can use with Hiru. The first one is using the Hiru all alone. You're able to mount this Hiru in front of a laptop or a tablet or a desktop using various solutions that we have. If you don't want to use the Hiru by itself, you can use it in one of our designated casings. These are called Usability. We have these manufactured in IRISBOND, and it's really nice because you're able to use the Hiru and plug it right in. But the Hiru is not permanently attached in the solution. Here we have an example for Windows using a game with eye gaze. Our same Hiru could be used in the other casing we have here at IRISBOND, made for iPad. All you have to do is take it out and plug it in. This same Hiru will work with the applications that work in iOS with an iPad, for example, predictable. So these more flexible solutions are able to take one Hiru in and out. Another option we have is from a partner who's created a fully integrated solution with the hardware. Here you can see Hiru is connected, but it is possible to remove it if you want to use it with another device. Lastly, we have a fully integrated solution with the hardware and the software. This example is from the GridPad, and the IRISBOND camera is actually fit into the device, and it can't be removed. But the advantage is it's got a really slick and cohesive integration. So those are some of the options we have. If you're looking for a solution that's integrated with something other than AAC, we also have options for that. Right now, we have one example that works with a coffee machine, as we saw earlier. This solution works with an IRISBOND camera, with the camera mounted directly on the device. Although this is used for making coffee, it still works as a great hardware integrated solution. So I'll make myself a coffee. So now that we've seen how Hiru can be integrated into hardware systems for eye gaze solutions and beyond, let's look at how the software that we make also provides a lot of flexibility. So our computer access software, EasyClick, is free for anyone to download on our website. And it actually comes in two forms. So we wanted to give kind of some flexibility built into the software. So we have two versions with that same concept of being able to control your world with your eyes. So the first side of this, or the first option, is beginner mode. So our beginner mode is really thought for early stage learning eye gaze users who are just trying to get used to the concept of eye gaze and begin interacting with the world using their eyes. So as it says here, beginner was designed for therapists and AAC specialists to work with the user together. So it's very simple to use and actually has kind of the pared down commands available. So that means that the most essential things are there, but nothing that is distracting or extraneous is necessary there. Other things that really make EasyClick Beginner unique are the invisible calibration, which really takes the pain out of calibrating. We also have options for making calibration more fun, like inserting your own personalized images, changing the colors and the sounds that go with that. And then again, we do have what's called our calibration button on our Hiru, which is used by often by therapists or assistants to the early stage user with EasyClick in order to start a calibration without causing extra distractions. So that's kind of the main, one of the main important things about EasyClick Beginner. Another thing that's really helpful for EasyClick Beginner is that you can save profiles so that so that you don't need to do all of these personalization or calibration steps more than once. So in EasyClick, you're able to save different profiles and use the same program with unlimited amount of users. So if you have, for example, a school or a center that works with multiple students using eye gaze, you're able to quickly and efficiently change between them without really having to reset any of those settings, which is really nice. Now moving over to the other side, which is Pro. EasyClick Pro is designed more for independent eye gaze users and really has all the tools that a person might need in order to use the computer like you would with a regular mouse. Here you'll find a lot more of a comprehensive menu toolbar. So you'll have many different options. You can use different types of click, drag and drop, you can scroll, you can go about your life and work as you would with using a regular mouse. So the good thing about that is also that all of the settings and the personalization is completely able to be controlled by eye gaze and accessible. So you have those two options there within our software. Okay, let's move on to our last trend in eye gaze, which is data. So what we mean by data is that basically data is so important to have in mind as we are moving forward with any developments in eye gaze. The information we rely on in order to constantly improve in our eye gaze systems at IRISBOND includes a few different things. The first one is a database of real users' eyes. The second is internal testing procedures. And the third is, of course, priceless feedback and opinions from real users. So let's look a little bit more in detail about those three things. At IRISBOND, every improvement that we make to our camera, it has to be tested thoroughly before it's sent off to users. So we do that testing here internally. And when there are improvements that are related to accuracy, detection, or calibration with the camera, those are also validated against a database of real users' eyes. So this database is really important as we do these improvements. And that's because the more types of eyes that any improvement is tested against, the better. Because in the end, there's lots of different types of eyes out there, and we want to make sure that any improvement works with all of them. So what we do now is collect eyes locally, as we like to say, to improve that database. And moving forward into the next year, we are also going to collect more eyes remotely and abroad. For us, it's essential to make improvements as well based on what real users want. So as we talked about, feedback is so important. We really know that therapists, SLPs, end users, those are the real experts in eye gaze, and the ones that are going to know the main things that we need in eye gaze cameras or eye gaze solutions moving forward. So to do this, we always collect feedback from our partners, from local centers using eye gaze, and from users around the world. So we're always open to hearing your opinions as well. So feel free to reach out if you do have any feedback for us in the future. And just to finish this, this section about data, I wanted to highlight a few improvements that we have implemented recently due to this information that, that we get from users, from our database, and from our internal testing. The first one of those is FPS. So FPS is the number of frames per second taken by the eye tracker. So when we say that there's options for FPS, that means that we've created the possibility to change the speed at which the camera is taking pictures of your eyes and taking information from the eye gaze user. So to give you an example of how this works and why it's important, a software working with early stage learning, maybe games or cause and effect activities, you may not need such a high FPS because less precision and accuracy is needed, and the battery life may be improved with a lower FPS. And on the other hand, a program using eye gaze as a tool for maybe diagnosing medical disorders may prioritize higher FPS, or those frames per second, in order to get more data and accuracy. So it really just depends on what use someone or an app is going to give to the camera. So that's one improvement that we've looked at based on data and feedback. Again, thanks to other opinions from real users, we've improved our recovery time of detection. This means that if I walk away from the camera and the eye gaze camera can't see me, and I come back, that it starts tracking my eyes again in 17 milliseconds. So you don't have to wait long to start your eye tracking experience again. Now, these last 2 points kind of go hand in hand because we've improved both the accuracy of the Hiru, which is something we're constantly improving, and we've improved the accuracy with many different varieties of eye types. So since we know that there is a lot of eye diversity in the world, we wanted to make sure that we are working hard to make Hiru work for everyone. So those are the main trends that we see coming for the future of eye gaze in 2022. I'll just leave you with this quote from IRISBOND, finishing it with, "We see it possible." At IRISBOND, that's our motto, and that's what we believe in. So thank you so much for your attention and for coming to this virtual event. Please keep in touch. We're happy to receive any of your feedback, questions, or opinions, whatever you like. So thanks so much. Bye-bye.